Seconds from going. Your notes should be open.
Mr. Painter, do you do yoga?
If you want to watch me fall over, yeah, I've done it before. My balance at age 50 is not the greatest. Let's say that.
Me and dance real fun. You're only 15.
15 years old, that's right.
Okay. Yeah. Really smart. Just get beat up. What? I listened to a song this morning. Do you do yoga? Like every day?
Yeah.
How does that change your life? Honest question.
I don't do like relaxing yoga.
What do you do? It's like that hot skin yoga.
No, that's so funny.
Okay, here we go. Okay, Eric,
We're in the zone.
Anna,
Sorry.
who else missed yesterday? Oh, Molly. Okay, yesterday's lesson 14.3, day 1. It's online. Please listen to it because otherwise it's gonna be tough for you. I'm leaving at school today at 3:30, so if you want to come in for help, 3:30 I'm leaving. So come in quick. Okay, here's the deal. I didn't finish day 1. So when you did your assignment yesterday, you probably got to the end and went, what are they doing? And you should have quit. You should have stressed out.
I have notes through me.
Okay, we didn't make it this far, did we?
Yeah.
We crossed multiple times.
Oh, we did?
Yeah.
Oh, okay. So should I just do one quick?
No.
Anybody want me to do one quick? Oh, Eric's laughing, so he must want it. Okay, here we go.
Eric wants it.
All right, here we go. Watch this. You guys are supposed to know when you have a triangle, you can use your SOHCAHTOA, your trig relationships, right? But it only works if you have what kind of triangle? Right. Do I have right? Yes. What's across from right is called the what? Hypotenuse. Okay. Here's the deal. When you start a problem, you look at the angle. You go, oh, I know 42 degrees. Okay. Then you start to say to yourself, what do I want to know? Well, I think I did A with you yesterday. I'm going to go do B. All right? This is what I want to know. This is what I do know. What are they called? What's this side called opposite the right? This is hypotenuse. Okay, so I know the hypotenuse. What do I want to know? It's either called the adjacent side or the opposite side. That's adjacent. So then you come back to this SOHCAHTOA. We talked about this yesterday, and I write down the ratios. Which one's adjacent or hypotenuse? Cosine.
Yes.
You gotta pick the right function. If you pick the wrong function, which happens on the quiz all the time, people pick sine when they should have picked cosine. You're gonna get it wrong. So this one would be cosine of what angle? 42 degrees. Adrian, same thing. Equals what? Adjacent. B over what?
28.
Hypotenuse. Okay. And then yesterday we talked about this. Cosine of 42 is just a number. It could be 5, 10, 15. It could be 1/2, 1/3, 1/5. It's just a number. But every number can be put over what? 1. So then we go cross multiply because this is called a proportion. 1 times b is b. Set it equal to the other cross product. What's this? 28 times cosine of 42. And, this one I don't think we did in class. Do you have that?
20.8.
20.8. Okay. Okay, now you do. Okay? And since we rounded nearest 10th, we're going to go 20.8. But most of these are all the same. They're all set up proportions, cross multiply, come up with the answer. Questions? Okay, now, why do students get it wrong? They just pick the wrong trig function. Now, when you come this way, these are the 3 trig functions that are known as reciprocal functions. So sine is a reciprocal function to cosecant. Cosine to secant, tangent to cotangent. And when I say reciprocal, I just mean flip it. Opposite hypotenuse becomes hypotenuse opposite. If you know the answer over there, let's say it's 2/3. What's it over here? 3 over 2. It's that simple. Okay? But we don't use this very often. We will eventually start using it more and more. But for now, I just want you to know there are reciprocal functions, okay? All right, we're done with day 1. Are you ready for day 2?
No.
Okay. You ready now?
I'm not confident.
Oh, that quick. All right, here we go. Day 2, we just continue. We just keep going. It says, now the story problems start to come. So now we have to kind of put it together what they're saying. It says the large glass pyramid at the Louvre, thank you, Louvre in Paris has a square base. The angle formed by each face and the ground is 49.7. So this is the ground. This is the side of the building going up, the face they call it. The angle it forms is 49.7. What is the distance from the center of the side? Well, the center of the side would be right there. Side of the base to the top of the lateral face. There's the top. What's the distance from the center to the top? So really, aren't we looking for the what? Yeah, but it's a building. That's, what's that called? The height of the building. I'm going to use H or HT. Okay. Now remember, you can't do these problems unless you have a right triangle.
Just take off.
Yeah, exactly. Good job. Just take it off. Don't even look at this side. We don't care. So really, we want that triangle. Now we need some information. We've got an angle. We don't know this face side. We don't know the height. Do we know this side?
Mm-hmm. Well,
Somewhere.
What is it? 17 and a half. Cut the length in half. 17.5. Okay. Then you just gotta look at it and go, what is it that I want? Do I want opposite, adjacent, hypotenuse? What do I want? Opposite. What do I know? What's this called? That's called the adjacent. You guys, once you know the two things, I want the opposite, I know the adjacent. Which trig function? It is, it's tangent. Okay, so we're going to do tangent of what angle? 49.7 degrees. Set it equal to opposite. What's opposite? Height. Don't know the opposite. Over what? 17.5. Got it. Put it over 1. It's just a number. When you type these in, they're just numbers. Okay? They're actually ratios that become numbers. Put it over 1, cross multiply. What's this when you multiply? H, height. And then this times this is more you using your calculator. 17.5 times what number? Whatever the tangent of 49.7 is. And that becomes the height of the building. 20.64. Okay. And you want, in a story problem, you do want to put in your units. 20.64 what? Yeah, we're in meters. It was meters, was it? Yeah, okay. So meters. Good? So why would you get this wrong? Picked the wrong trig function. Maybe you read it wrong. That can happen. So a lot of times students will read it and they'll go, oh, I don't get what I'm looking for, or I don't understand it. So that's why you get wrong. But for the most part, the solving part of it isn't that bad. Okay, the next problem talks about an airplane, and it these 3 words. Even in pre-calculus, when I teach that, students still just get, they don't get this angle of descent. So I'm going to show you a picture. You have to kind of, in your mind, it's got to make sense to you so that every time you read a story problem, you hear those words, angle of descent, you know what they're talking about. So we're talking about a plane. You got to picture yourself in the plane. You're the pilot. You're looking straight up. This is called the horizontal look. You just look straight. That's your eyesight, straight up. Now, angle of descent means you're going to look which way? Down to the ground. So you start looking down. There. That is the angle of descent. Here's the angle, the horizontal with where you look. If you're looking down, That's the angle of descent. Okay? I'll just write descent.
So is it just your hypotenuse?
I think it's spelled that wrong. Is it DI? Descent? No, it's not. Okay. Is it what?
Just your hypotenuse?
Well, you gotta wait because you don't know the story. Yeah.
Is it the, like, if you make it a triangle, so you go down and to the right, would it just be that top angle subtracted by, or 90 subtracted by the top most angle? And all of the angle of descent or something?
No.
Well, angle descent is just here. I'm flying my plane. I'm looking out. I look down. You guys see this angle? That's the descent. Then there's something else called the angle of elevation. I look up. I see the moon. I'm looking at the moon. This is called angle. Whoops. This is called angle of what?
I think you're ascension.
Elevation. So they'll use these terms on you, and you gotta know. It's just the horizontal. I'm looking out straight. Then look down, descent, up, elevation. They form angles. Okay. So when you look at this next problem now, you gotta make a picture of this. Okay. So maybe you can do that without my help. Okay. Try it. Just try it. Draw a picture. And you will need a triangle because they're going to ask you a question. Oh, that's a bad play. Anyways, there it is. That's the angle of descent. You're in the plane. You're looking straight forward. There's your horizontal. You look down at the airport runway, and you create what degree angle? 3 degrees. So you should have done this already, I hope. Then it says, if the airplane begins its descent at an altitude of what?
4,000.
Where's that go?
The
Altitude is how high you are. So this is the plane. Go to the ground. Okay, that's 4,000 feet in the air. Okay, that's altitude. Now, from this spot, continue to the runway, and do you see it?
Can you build the same triangle?
There's your
The
triangle.
other way.
See it right now?
Can you build the same triangle?
Yep, this way. Yep, it's the same thing. Okay, but now, the ground and the altitude are right angles. That's vertical versus horizontal. So there you go. You've got your triangle, right triangle. Okay, I know this. What I'd really like to know is inside the triangle. What are the angles?
Just subtract the 3 degrees from 90, and that would be that top angle.
Okay, so you're telling me the horizontal and the vertical are 90. So 90 minus 3 makes what? 87. So John says that's 87. John, you're right. Okay. Or you could go over there and say, well, that's 87, that's 90. What's left? 3. So this is 3. I mean, now we're getting more numbers, okay? What is it that we want to know? What is it's what? Straight line distance to the airport. Okay. Now they didn't say straight line distance from the tip of the nose of the airplane down to the airport. They just said straight line distance. So if the airplane's right here, how far does it have to get to that point right there? Well, actually it's right here, but on the ground, the straight line distance is this far. So you are being asked to find this distance. This distance from the nose of the plane down to the airport, they would have had to say something like, wherever the airplane is right now to the edge of the airport. That would be from here to here. So we're looking for this one. So now the question becomes, how are we going to do it? Are we going to pick the 87 and work with it, or are we going to pick the 3 and work with it? I heard 3, so let's do 3. Here we go. I know what Opposite, I wanna know what? Adjacent, what's that?
Tangent.
That is tangent. Tangent of 3 degrees equals what? 4,000 over what? Adjacent. The adjacent's D, right? So now what? 100 over 1. Make it a proportion. Cross multiply. 4,000 equals what? Yeah, tangent of D, or sorry, tangent of 3 degrees times D. You know what, Isaac, I'm going to put it this way instead. D times tangent of 3 degrees. This is just an equation. How do you get rid of a multiplier? Say again? Division. Okay, division, yep. So he says divide this by what, Isaac? Tangent of 3. Tangent of 3 and tangent of 3 are the same number. They'll just cancel out. Get over here and do what? Same thing. D, the distance from the ground, straight line distance to the airport is what?
1,333.
1,000?
Is it like big number?
A big number, it's big. Yeah.
76,000.
76,000.
324.55.
324.55, okay? Okay. Is that meters, feet? Feet? Okay. Feet. There it is. That is the beat. Hang on. That's not my, she's not my, it's, what's this?
Computer lab, registration for class.
Okay, which one's wrong? I don't know. Cassie Kuntz?
Not in this class, she's
No.
probably.
Probably running there.
And I think she's in Nelson's class.
Okay, go through that and see. Okay. Anyways, hey, there's another way to do this problem. I just want you to know that. You guys, if we pick 3 degrees, that's our answer. What if we would have picked 87? Would it still work?
Probably.
Yeah, of course it would. Because it's all the same. So if you pick 87, you guys might want to write this down. If I pick 87, what's that side called?
Opposite.
What's this side called?
Adjacent.
Adjacent. What's it called now? Which trig function? Tangent of what? 87 degrees equals what? D over 4,000. And by the way, this would have been probably the easier way to do it, because look, when you do this, what do you get?
D.
You get your answer right away. D equals, and then 4,000 times tangent of 87 comes out as 76,324.55 feet. So here's the bad part. The bad part is, in trigonometry, there's not one way to do it. There's sometimes 2, sometimes 3, sometimes 4 ways to do it. And we're not all going to do it the same way because we all look at problems differently. So you're going to go home at night and, maybe you think this way and somebody else thinks that way. And guess what? If you follow the rules, these are the rules, by the way, you'll be fine. It's just we all look at it differently. This would have been the easier way to get it, I think. Okay, now we're going to shift gears. Here's what happens. You guys have been finding the missing side, the missing side, the missing side. Now find the what?
The angle.
Missing angle. Okay, so this is a little different. Look over there, you got a triangle. What is angle what? A. So you got to go find A. Here's A. Okay, if you want angle A, you still got to tell yourself or ask yourself, what do I know? I know what? Opposite. What else do I know? Hypotenuse. Okay, so if I know those two things, I have to pick which one. Sine. So you'd say sine of what? Angle A. I don't know A. Okay, but I do know the ratio is what?
4 over 10.
It's 4 over 10, right?
2
Okay, or 2 over 5. If you want to reduce it, you sure can. I'm just going to leave it for now. Now here's the deal. Your calculator's programmed to tell you sine of 40 degrees, sine of 47 degrees. It's programmed. Okay, this is A. This is you asking for the angle. Well, this, you gotta think, in algebra, there's always ways to get rid of things in your way. What's in my way here? Plus 3. What do I do to get rid of plus 3? Subtract 3, subtract 3. What's in my way right now? Multiplication. How do I get rid of that? Division. What's in my way right now? X squared. How do you get rid of squares? Square roots. Now here's the deal. Every time you see something, you always go, I'll just do the opposite. Or another name for that is, I'll do the inverse operation. What undoes addition? Subtraction. What undoes multiplication? Division. What undoes sign?
Cosecant.
No. Good guess though, because you picked the reciprocal. That's not right though. That's a good
Really,
guess.
tangent.
What?
Tangent.
No.
Eight is on.
Cos.
Ooh, you're-
The one with the letter eight.
Okay, Travis says it's the one that says sign with a -1.
That's why I said negative.
Oh,
That's what
okay.
I said.
There's a name for that.
Sign.
That is called
Oh,
inverse sign. That's an inverse operation. That's an inverse operation. That's an inverse operation. You'll do the inverse operation, which is inverse sign. Inverse sign kind of wipes out sign, just like that. Choo, choo, it's gone. So then you say A, my angle, equals, I have to do that on the other side, don't I? Inverse sine of the ratio 4/10. So inverse sine is going backwards. It's saying, here's the ratio, what's the angle? Punch it in. Punch it in. Punch it in. Don't wait for others.
23.5.
23.5? Okay.
0.6.
Okay. Wow. 0.6. 0.6. Okay. All right. So this is Taylor's answer. What do you guys think? Yeah?
Yes.
Yeah? Okay. So guys, if you ever get cosine of A or cosine of B or whatever, you do inverse cosine, inverse tangent, whatever. I want to just quick give you another one. Just do this. I want tangent of angle D, and I will tell you the ratios. It's 1/10. Okay, you got 5 seconds. I'll do my 5-second count.
That's basketball.
Not fast enough?
Is this your just your exercise in for the day?
5.7.
What is it?
5.7.
5.7 degrees. D. How's that? Is it hard to get an angle?
No.
But to get an angle, you got to know what? You got to know the ratio. So there's just 2 different ways to go. Do I want the size or do I want the angle? Okay. Good. Okay, go back and. Oh, we already did it, didn't we? Okay, sorry. Okay, let's go this way. Okay, now this problem, this is the same thing. Find the missing side, find the missing angle. But the problem is they don't draw the triangle for you. And some students, they get to a quiz and they can't even draw the triangle. So we got to talk about this. We're talking about triangle ABC. Angle C is what? Right. So you might as well just do this. They just told me I have a triangle. It's called ABC. Where do I put the C? Where do I put the C? Yeah, right here. Okay. Where do I put A and B?
Wherever you choose.
Well, yeah, exactly. It doesn't matter. A is here, B is there, or vice versa. Okay. Now, you notice that when I do angles, it's capital letters? What do I use for the sides? Lowercase. So where is side C? Yeah, it's opposite of angle C. So opposite turns out to be the hypotenuse. Okay, where's side A?
Bottom.
Okay, bottom. All right. And B is over here. Okay. Label what you know. You know angle B is what? 20. Side A? 6. Okay. In these kind of problems, they want you to solve the triangle. Get the missing stuff. What's missing? What don't you have? Angle A, there's one. You don't have angle A. You got to figure that out. What else? side B and C. There you go. So now at least you know what you're looking for. You're looking for these three things. That might be 3 points, 4 points, 5 points on a quiz, right there. Now what's really simple for you, I hope? Finding angle A. I hope it is. Angle A, if you look at this triangle, you use 90, you've already used up 20. What's in a triangle? Well, no, but what's in a triangle? 180. So you've already used up 90, you're down to what? 90. Take off the 20, 70. I might do something like this. I might just say it's just 90 minus 20. Because this 90 right here took care of 90 of the 180. There's only 90 left. That was pretty simple, I hope. Okay? Now B and C, that's nothing more than what you and I have done. See if you can get B. Everybody, see, go get B. If you're looking for B, B is the opposite. You already know A is the adjacent. Opposite adjacent is? I would have used tangent, yep. So tangent of what? 20 degrees equals what ratio? B over what? B over 6. 1 times B. B. 6 times tangent of 20. Is that what it is? Okay. Isaac says 2.2. Is he right? Okay, I heard one. Okay. 2.2. It did say nearest 10, right? So we'll go 2.2. All right. Now we want C. Well, stay with the 20, guys. Just stay with the 20. Even though you know that's 70, let's not use 70, because what if 70 was wrong? You want C? C is called what? Hypotenuse. You already know the adjacent is 6. Adjacent, hypotenuse. Adjacent, hypotenuse. Cosine of 20 equals adjacent 6 over C. Yes? You okay? All right, cross multiply. Here we go. 1 times 6, 6. C times cosine of 20. Try the best you can to stay organized with this stuff. It can mess you up. Okay, opposite of multiplication? Division. Divide by what? Cosine. You want to get rid of cosine of 20. Knock it out, knock it out. 6 divided by cosine of 20 will be your answer. C is 6.4?
Yes.
Yep. Okay, 3 yeses. 6.4. If you say no, it's okay. I mean, you want to get everybody saying yes. Yes? 6.4 okay? Okay. Any questions? Yeah, go ahead, Gavin.
Couldn't you just do the Pythagorean
You could. Yes. He already said? He said, could I just do the Pythagorean theorem since I know this is 6?
Good thinking.
I knew this was what? 2.2. You know why I don't do that? Because I'm in trig. I'm going to stay with trig because I'm trying to teach you guys trig. Yes, he's right. You could do Pythagorean theorem.
Is that part of trig?
It's all interconnected. Yeah, trig is a lot of geometry kind of stuff. But you can. I just don't. I'm not going to do it up here. Okay. All right. Good? Now, there is another one over there. It kind of disappeared on me. But you do this one, though. This one, they give you side-side. They don't give you any angles. I think this one's a little harder. But you got to start by drawing the triangle.
Use the same.
Go draw. Oh yeah, it's the same directions. Same directions. Angle C is right. What was BC?
B is 7, C is 10.
C is 10. Okay, thanks. All right. That's what I see. The given information led me to believe this is my triangle. What am I missing? Angle A. What else? Angle B. Okay, angle A. Angle B. And side A. So this is your answer on the quiz, or the homework, or whatever. Okay. All right, ready? Everybody want to talk about it? What do you want to do? Go ahead, John.
Yeah, I just use the reverse Pythagorean theorem to find A.
So you want to use Pythagorean theorem to find the missing leg. Okay.
Yeah.
You get what John said?
Yeah.
And Gavin said it too. You can use Pythagorean theorem, but I'm not, because I'm teaching tricks.
It's just super simple.
So you can, John, I just said it. You can do it. But John, I'm teaching trick. So, guys, I can't do, listen, because I'm not going to do the Pythagorean theorem, I can't find A first. I got to go find the angles. So now you got to pick an angle. Which angle?
A.
A? Okay. I want A. Well, what do I know? This side and this side. What are they?
Adjacent.
Adjacent and hypotenuse. Okay? All right? So, adjacent, hypotenuse is which one? Cosine. Cosine of A equals what over what? 7 over 10. Okay? And then we just learned this on the previous page. If you want the angle, you got to get rid of cosine by doing what? Inverse cosine. And then, of course, that will get you A. But then you got to do inverse cosine over here. And that helps me get the angle. A is something like
45.6.
40 what?
5.
0.6. Okay. So there's A, right? Okay, so I go back up, fill it in, put it in quick. 45.6. Once you get A though, guys, I think angle B is really simple now, isn't it?
Sure.
Take off 90, you're down to 90. Take off 46.5, you're down to
Whoa.
44.5.
44 what?
0.5.
45, okay, gotcha. So 44.5. Oh, wait a minute.
It's 44.4.
Wait, okay, if that's a 6.
Yeah, it's a 4.
Oh, I wrote this wrong. I'm sorry, I wrote that wrong. Okay, that'd be a 4, you're right. Okay, so 4. Now, I'm going to stick with Treg to get my side A. Even though Gavin and John have both said it, you can do Pythagorean theorem. I'm not gonna. So if I want A, then I'll pick an angle. I'll say, let's just pick A, or B. I want this side, it's the adjacent side. What do I know? I do know the hypotenuse is 10. Adjacent hypotenuse. Which one? Which trig function? Cosine. Cosine of what? 44.5 degrees equals adjacent A over 10. Hypotenuse. Put it over 1. Cross multiply. A equals 10 times what? Okay. And you would come up with, is something wrong here?
It's 44.4.
44.4. Yeah, I'm using ohm because I wrote that wrong too. Jeez. Okay. Anyways, what does it come out to? A comes out to what? 7.14? Okay, 7 point, I think, we'll just go 1. 7.1. Would the Pythagorean theorem work? Sure it would. So I'm trying to stick with trig since I'm teaching trig.
What if with the Pythagorean theorem, based off what we learned yesterday, would have been left as square root of 51?
Or do you want it?
So,
But that's because it didn't say to leave it in this route.
Oh, yeah, and it didn't say, oh, you're thinking, but yesterday we said, you're thinking of the problem that says, find me the 6 trig ratios. Now, ratios are different. Ratios are numbers, a number on top, a number on the bottom. They want the numbers. And when they say that, they do say simplest radical form.
For this, you just want us to solve out.
This is like, eventually this stuff is talking about story problems. Like, how far is it from
Yeah.
this island to this island? And you want to know,
Do you want like the approximation then?
oh yeah, yeah. And you probably go to the next step. Probably. Okay, now, you guys, yesterday, you were given a book assignment day 1. Today's day 2, so it's all together. On Monday, it comes in. There's 10, 12 minutes left. I want you to do number, and if you've already done it, you don't have to do it, just, I want to make sure you can do some of these problems fairly well. Will you go do 27 in the book right now? 27. By the way, 27 is not anything I taught here. It's yesterday's problem. Yes. What?
Yeah. Z table. Z table.
Yeah. It's one up in those bins. Look at those little slots. More towards the top, I think. Okay, 27. This would be yesterday now. For those of you that don't bring your book to class, this is the problem. It says, take a triangle, a right triangle. If you know cosine of theta is 7 over 20, it says this, let theta be one of the acute angles. Well, that's 90. Which one's acute?
One of those two.
One of those two? No.
The bottom one.
The bottom one?
Yeah.
Guys, they both are acute. What's acute? Less than 90. This is already used up 90. What's left? 90. They have to both be less than 90. You put it anywhere you want, theta. Where do you want to put it? Bottom, top. See you later. Have a good weekend. Bottom. Okay. So put it there. Now, tell me, what about the 7 and the 20? Where do they go? Okay, yeah, this is adjacent over what? Hypotenuse, right? So you'd have to put the 20 here, you'd have to put the 7 here, and the only thing you don't know is this side, opposite side. So how do you get that opposite side if you know a leg and the hypotenuse?
No, I like, right?
You could do sine, yeah. You could. But I won't fight you anymore on this one now. What? Say it again.
No.
Yeah, say it again.
No.
Say it again.
Pythagorean theorem.
You won't?
Pythagorean theorem. Pythagorean theorem. I just go 7 squared plus what? Missing side squared, x squared, equals what? 20 squared. That's 49 plus what? X squared equals 400. X squared, what are you doing? Minus 49. Tyler, if you're not gonna work with me, then don't be just, getting everybody's attention over here. Okay, stop.
already did this.
That's good. But that's not what I asked. Okay, what is it, guys? 49 goes over 3 what? 351. Okay. Square root of this, square root of that. X equals. Okay, so say that again.
3 square root of 39.
How'd you know it was 3 square root of 39?
Took the time to plug it in constantly until I found 3 worked.
9 works.
I mean 9.
Yes. Okay, I'm glad you said that because some people have these calculators that can actually simplify this for them. This, if you simplify, 9 goes in there how many times? 39 times. So your answer is? Okay, 3 square root of 39. So what's the missing side? 3 square root of 39. Okay. Now, the missing side of a right triangle, don't just do the Pythagorean theorem. Because you just want to get these ratios on paper and just now start putting numbers in the right spot. Taylor, 1 second here. Do you guys know that cosine and secant are what kind of functions? The reciprocal function, trig functions. Okay, so if this is 7 over 20, this one's what? 20 over 7. Now, they gave you the easiest one right away. The harder ones are coming. So go get sine, go to secant, go get tangent, go tangent. See what you get. We did this yesterday, guys. So I'll give you about a minute. Go.
So why do we use the Pythagorean theorem on this and not the other stuff?
Because if you did trig on this, you would get a decimal answer. And when this problem says find the 6 trig ratios. Ratio is a number over a number, a number over a number. Okay, you're gonna get decimals, and it's just gonna mess you up. It just doesn't make sense. Plus, they do say in simplest radical form. Okay. Okay, keep going. You guys haven't got it yet, have you? Okay, 30 seconds. Try again. Well, okay, this is you finding the use of and of course, then they say, you guys need to is that true? Well, one second. So now, you can look it up and say, oh, that you're done. You're done.
What's your favorite?
What is the Z? You're done.
What's your favorite?
Oh, the next one.
Nope, guys have an answer.
Oh, if you did, I'd be like, bye.
Mine is resident.
Yours is looking at your chart. Yeah, that's the part I can't tell you. That's you. That's not me.
But I don't tell you that I
No. You're basing your Z's.
don't. I was making
Your information. That's all they do.
I did not.
I understand what the table tells you. Okay, ready? Quick, sign. Sign was what?
3 squared root 39 over 20.
Say again?
3 squared root 39 over 20.
Yes, 3 squared root of 39 over 20. Okay, and then you said, I hope you said, this cosecant is a reciprocal function of sine, so I'll flip this thing and get 20 over this. But yesterday the problem was we just can't have radicals on the bottom.
You do
Multiply bottom top by what?
Square root of 89.
Okay, 39 square root. Root 39. Bottom gives you what?
117.
What's this? 39
39.
times 3?
117.
117. On top, you get what? Right?
See.
And 20 over 117 is not reducible, so you're just done. This is the only messy part, and it's not that messy, because you're going to take your calculator anyways. Multiply that out. Taylor, you got tangent? No? Faith, you got tangent done?
3 square root of 39.
3 opposite side of theta over here, over adjacent 7. That's good. Done. Cotangent is just the reciprocal. You would flip this over and say, this is my answer, right? Multiply the bottom by what? Root 39, root 39.
7 square root of 39
Over
117.
same denominator, because it's the same problem. 7, what is that? What problem was that?
27.
27. That was yesterday's problem. Now, you got a 2-day assignment. You got to get it done, and we all know Sunday night is 4 hours of football. So don't save it for Sunday night.
I'll say it for Sunday night, I'm not watching.
Tell me your favorite commercial when you get back.
We'll watch it, except
That's
for
the
the
only
Puffy
reason why
Monkey.
I watch this.
Nothing about that.
Which one?
Puffy Monkey.
Wow. There's no way they bring that back.
There's
no way that-
Puffy, Mark Monkey, and Arcade. And for the Mountain Dew King.
There's no way they bring it back.
I got more.
It's the
Last year?
Yeah.
Okay. Oh, wait. I'm waiting. Give it to you.
I love their vision.
How much do you have? It's nice to get this over.
Actually, like one of my.
Yes, it is. I don't remember this at all. This is last year?
Yeah. Nothing tops that.
Oh, I think you're pretty biased on that one. I don't know.
Monty, let's
You must have something really favorite.
Is this?
His name's Taylor.
Yep.
I didn't know that. I was calling him Taylor. He's so like a friend. And she's like,